time is over. I will start, but maybe someone else will come because my wife and kid is missing. So I decided to wait for them. So they just went to another room. So let's wait just a minute more. I see that the room is nearly full. Thank you all for coming. I know it's an exciting project. It's an exciting project for me as well and for our team. So I think I can start. Thank you for coming. It will be a 1-hour presentation. I think I have content that I can squeeze into 1 hour, but more are on the GitHub page or on our web page. You can go and visit and find. It's all open source. And last thing first, we are looking for enthusiasts and HAMRADIO guys like us to support us in this project. We just brought this idea to the stage that after the HF part, now a VHF, UHF transceiver, SDR transceiver can be done and implemented by the radio amateurs. So maybe this is one of the first, I would like to say, samples, maybe the first one on Q100, but I know that there are some other SDR transceiver projects around. So let's start. The agenda is first, of course, we will talk about the story, why we did this, where we start. I will try to explain it in the technical wise, not chatting, we need this, we need that, but I would like to explain the history of, or the evolution of the project, because this project started 5 years ago in our heads. And in 5 years, the biggest achievement was done within the last 3 months before Frederikshavn. He said, yeah, we need to finish it before Frederikshavn, and it happened in 3 months, as always. Then, who we are, the design goals, what does this device do for us, how it works. We will do some system overviews. I was planning to go into the software details, but it will be too complicated or detailed, so I just cut it out. I will just go through from the surface on that area, but most probably we will have some online sessions on discussing these different parts of this project, maybe on Zoom or in any other platform to improve the device. Then mechanical overview, the current status we will talk about, and what we are planning to do, and at the end we have a demo. Of course, we have a demo effect that I will talk about. First, I presented this in Open Source CubeSat Workshop 2020, which is 4 years ago, I guess. And I was thinking about a portable QO100 SDR transceiver. Why? Because I'm a Turkish amateur, and in Turkey, you know, you hear about the earthquakes all the time. And I was thinking about a portable station that I can carry with myself and easily set up in the field and start communicating. So I was thinking about everything to fit in a suitcase. You open it and use it. Normally, by the way, QO100 usage in Turkey is forbidden because we don't have the 13 centimeter span in Turkey for radio amateurs. Since last year, we have it because of the earthquake. So that was the plan. It was just a plan. It was just some drawings about what it should do, what the screen should look like, what capabilities it should have, which components can be used, etc. For example, the idea to do a Manpack started from the portable software-defined radio project. It was a Kickstarter project. I saw it. It was using an STM32, I think L4, and it was a very tiny device. So I thought I can put some up converters, down converters beside that device, and can make it a portable project. But I was never able to get a PSDR to see what's going on, or I can do some reverse engineering on it to build my own. But I bought the Monka M0NKA, which is a good device, and worked on that and had some achievements to do some down conversion, up conversion, but the hardware was very complicated. It's not a device for everybody to build and use. The codecs are expensive, not easy to find. All the components are really surface mount, not easy to mount. So I said, yeah, the idea they're okay, the software okay, I will start reading the code, but Monka hardware cannot be the base of our design. Then time passed, maybe you know VB2CBA, he was working on the micro SDX. And with the micro SDX, all my ideas changed again. Yeah, now 8-bit microcontroller, only 10-bit ADC, you can only do something of, let's say, 1,000 kilobytes per second, kilosamples per second. If this can do it, I can do it with a better MCU quicker. So the challenge started for me. First, I used the micro SDX version 102. This is 102, right?
Yeah.
Yeah, 102. Then I put a up converter, down converter under it, and use that to communicate via the satellite. Then I said it can be smaller. Thanks to Bob, he put the USDX mono, which was very small. I mean, maybe 2 centimeters to 5 centimeters, something. It was a very tiny device. So also I implemented an up converter, down converter for this, and I had at least kind of working QO100 terminal. While I get there, these are my evaluation boards, as you see. They are all like up converters, down converters, and up converters and PA. They were all on some breadboards or about that, but it was working. So it gave me the belief that I can do better, and I started documenting a new approach to this QO100 terminal, like, you know, in the SDR console users know that to look into the beacon, the center beacon to, how can I say, to solve the issue with the LMB frequencies moving around and having a stable frequency. I thought I can have 2 MCUs, 2 receivers, one is locked into this center frequency. And I concepted all those ideas to be implemented. But I didn't implement anything because I was just presenting. I was coming last year, I believe, maybe some of you were there, in a room here in Friedrichshafen. I presented the project again with some more details. But this year we have more details. The design goals didn't change too much. We thought it should be software defined, because the future is in the software defined, so we can implement any protocol or any modulation that we would like to. It should be portable, that's must, small, cheap as possible. No definition for cheap as possible, but cheap as possible. Should be simple, so everybody can build it. Everybody can try to implement some software on it, or everybody can get their soldering iron and modify it. And if it's cheap enough, then you don't care about you lose the device or not. And it should be expandable, the key of software-defined radio. So the hardware and software, if you think you can use this in another platform for another project, it should be modifiable easily. My son and wife is here, so I'm safe. So it should be battery powered because it will be Manpack, it will operate in the field. it should be stable. No definition for stable, but stable enough, let's say. Open source is a must for me. Collaborative, we need friends to build this and have fun together. And non-profit, of course. Everybody in this room, I believe, has a man cave in their house. This is our living room. It's the living room. Thanks to my wife, we work here together. And I'm an electronics engineer and space scientist, and I like doing hardware and software, both. I like space communications, the deep space network and all other things, and we have a project called Mars on Earth project, doing some space, I don't want to call them researchers, but space experiments with kids for space. And this is our man cave, and we have dishes and antennas outside on the backyard. Who we are. As I said, I started this 5 years ago, but it ramped up, let's say, a year ago, with the group called Atölye. Atölye in Turkish means workshop. It's a Zoom channel that we build up. It's 24 hours open, so you join to that channel, you see someone else doing something, and he asks you questions, you ask questions to him, so you can share information back and forth. And normally the maximum number we had here in Turkey was around 50, but mostly we are 7, 8, 10 people online talking to each other. It's not easy to go to the club and come together because Barb is in US, I'm in Finland, and most of the rest is in Turkey, so some of them are in Germany, so it's not easy to come together in a club and talk and build something. So Atölye is our workshop that we do something, and this project is an outcome of this workshop. PCBs are designed somewhere, hardware designed somewhere, software implemented somewhere else, so we gathered all those together. Do you have something to say about it? Working remotely?
Well, yeah, I'm stationed, by the way, my name is Bart, everyone calls me Bart, Barbara Cicero, Whiskey Bravo. Whiskey Bravo 2, Charlie Bravo Alpha. I have to use this one.
Amplification.
So, yeah. When Boris first mentioned about this, I got very excited because I did a lot of PCB design. Maybe you know me about micro STX and ADX, this guy. So we cross-encouraged each other. What we did was, he lives in Finland, my son lives in Finland. It started last year, November, in the kitchen of my son's apartment. On a piece of paper, we first outlined this. And then, thanks to Boris, he advanced a lot. I mean, we owe him a lot on this. I just did the PCBs and some mechanical designs, which I'm going to talk later. Back to you.
Thank you. If you revisit back the design, there was a design in my head that I was trying to document to fit to meet these goals, but it was not fulfilling all my thoughts about building an SDR device with up-down converters. If you go back and see the micro SDX, which is the QCX, modified QCX from QRP Labs, it's very simple. You have a toll detector, FST3253. It outputs the IMQ using these filters. Then you have an ADC of 10 bits, which is very slow, of course, and you just digitize the IQ data, and then you do the demodulation. On the transmit path, this device uses a different approach, that it uses the SI5351 to modulate something, but the approach was very simple to use. So, as I say, thanks to Guido, of course, because his code showed that you can do complex mathematics in a very simple way. The SSP demodulation is 2-3 lines. The transmission is 2-3 lines. the whole code, it looks a little bit crowded, but if you dive into it, it's a very simple code to read. Thanks him, because it gave us the impression that we can develop this, redevelop this software on another MCU. So, then Argente Marvelde, that's the GitHub page. While I was thinking that, and we were discussing moving to a powerful MCU, we found this project. Yes, it's already done. Someone used